Hello, everyone. Thanks for the introduction. My name is Denis Magda, and I'm a product manager at GridGain, and also I'm a vice president of Apache Ignite project. I joined GridGain almost 2 years ago as a software engineer, and around the same time, I became an Apache Ignite committer. All this means that throughout this conversation, you can expect to ask me all the tricky questions you might have, because I'm still a kind of technically qualified person who is ready to address all the technical questions around the Apache Ignite product that I'm working on. And our today conversation will be about a specific use case, which is how to use Apache Ignite altogether with Apache Spark for the IoT scenarios, for the Internet of Things projects and deployments. To be more specific, we are going to follow this agenda. First, before we start talking about anything, any use case you have, we need to gather different requests or demands. What have to be done? What are the requirements? What we need to follow? Once we review all the requirements and demands coming from the IoT space, I would suggest you one of the possible IoT software stacks. In particular, we will take a look at different layers that has to be implemented, that has to be a part of your platform, which is an operating system or real-time operating system for your edge devices, or the devices like smart meters, vehicles, wearables, and all this stuff. On top of that, on top of your devices need to send different information. And there should be a layer that will get this data, aggregate this data, enrich it. And finally, all the data must be placed into some storage. And here I would be talking about a hybrid transactional and analytical platform. The platform that can perform and execute both transactional and analytical workloads. And finally, we need to talk about application APIs that will be provided to us on top of that H-type platform. And eventually, if we have enough time, I prepared a cool demo for you that demonstrates how to use Spark and Ignite for the different IoT scenarios. It's a kind of a code template that you can use in your own production environment. Okay, let's move on with our demands to software. If to talk about IoT applications and IoT solutions, as many other applications and deployments, they do require us to ingest data in real time and process the data in real time, giving an immediate feedback to our IoT deployment. For instance, let's imagine that we are driving, we are sitting behind the wheel of a self-driving car developed by Tesla Motors or by Google. And all we know that such cars are equipped with many, many thousands of different sensors that constantly send different information around the environment to a specific central software. And that software has to process that information in real time. Otherwise, if some delay happens, something unpredictable can arise, like a car accident. And for sure, such a system has to be able to ingest and process data in real time. Next, as for the APIs, as for the querying capabilities, IoT applications, they are not that different from many other applications, web applications and enterprise applications. They also want to have some useful and convenient API, like SQL queries. So, which means that if you store your data coming from your IoT field into some HTAP platform or some database, that database should be equipped with SQL capabilities. Also, if you are talking about sensors or wearables that send different geo-related information like location, then it will be good to have if the platform supports geospatial queries that allows us to query using different location parameters. And finally, for some advanced systems that do voice recognition or computer vision, we need to support BI and machine learning capabilities. We need to have them as a part of our platform. And finally, sometimes we do start with a kind of small deployment. But later on, the more sensors, the more wearables go into the field, the faster and the bigger our software stack should become. This is why we need to design and need to make such characteristics like high availability and scalability at the core of our software stack system. We need to be sure that the system can scale out easily and it will be highly available all the time, regardless what happens to our software. And if to speak about the software in general, here is I just want you to suggest one of the simplest software stacks. It's pretty high level. The whole point here is to demonstrate what are the main building blocks that exist in every IoT-based solution. At the bottom one is your operating system that will be deployed and used on your edge devices, your sensors or your wearables. If your sensors or wearables are powerful enough so that you can run embedded Linux there, then you're good to go. But at the same time, if you're trying to deploy your solution on constrained devices, on microcontrollers, then the only way to use, the only choice for you is a real-time operating system, like the ones developed by ARM Limited or by other companies from that space. Next, once we are done with our real-time operating system for our devices, we need to gather the data and transmit the data for the further processing to our storage, to our processing engine. And here is, we might need to have so-called data collection and enrichment layer. That layer actually receives all the information coming from our devices, aggregates it, transforms, enriches whatever is needed, and sends it back to our distributed storage, our distributed edge tab platform, which stands for Hybrid Transactional and Analytical Platform. That platform will do several things for us. First, it will be our distributed storage that can be scaled out easily. And on top of, and finally, that platform will provide all the APIs needed for our applications, such as SQL queries, distributed transactions, distributed computations, and so on and so forth. And all these APIs will be available to our final applications, to our applications that somehow will leverage from the data that is coming from our edge devices. And here is today I'm representing Apache Software Foundation, and for this software stack I will introduce you the software that is being built inside of the foundation by different communities. For instance, if you're trying to find some reasonable and good real-time operating system for your devices, it's a good idea to look at the Apache Minute operating system, which is the system that is designed for really constrained devices or microcontrollers. Next, when the data will be sent from Apache Minute-enabled devices, it can be received by a variety of different frameworks and platforms such as Flink, Spark, or Kafka, depending on what you like most. But today we are going to talk about Spark as a solution for this specific data collection and enrichment layer. Finally, when all the data is gathered and transformed, it will be stored in Apache Ignite, which is our hybrid transactional and analytical platform. And if the data is located in Apache Ignite, then you are able to leverage from all the APIs that we are going to cover in the following 20 minutes, available in Ignite. And plus, Apache Ignite seamlessly integrates with Spark, which means that you can connect to Apache Ignite cluster from your Spark application and use RDDs-based APIs or execute SQL queries. I will show how you can do this in practice. Okay, let's now quickly go through all these layers and all the components you saw. For instance, Apache Minute, once again. So this is a real-time operating system that is optimized and works on top of microcontrollers powered by the microprocessors of Cortex-M family and MIPS and RISC-V. The beauty of this platform is that, as many others, it provides you with all the APIs needed to connect to your different sensors and hardware components on your edge devices. And next, when you let's say when you gather information from your devices, you need to send it. And there are different multiple ways how you can do this with Apache Minute. You can use Bluetooth, you can use Wi-Fi, and also on top of this low-level networking protocols, Apache Minute supports convenient TCP/IP and UDP layers. As for the installation of application and system upgrade, you don't need to go to the field if you need to, if you need to roll out new version of your application or you need to upgrade Apache Minute. You can connect to your devices remotely and do all the updates and installations sitting at the office, which is essential nowadays for all the IoT applications and deployments. Next, data collection and enrichment. And here is we are talking about Spark. So as you know, as all you know, there is a kind of good component, an excellent module that is available as a part of Spark, which is called Spark Streaming. Spark Streaming, as we know, is based on top of Spark Core functionality, and the whole point of this streaming component is that you can easily connect to Spark, to a cluster of your Spark machines from your devices deployed somewhere in the field, and ingest all the data, transmit all the data from your devices into the Spark. And right after that, Spark will receive this data, it will transmit it, enrich, and send it later to Apache Ignite cluster, which will be our final storage. And now let's talk a bit about Apache Ignite. So what's Apache Ignite in general, in several words? So Apache Ignite is a memory-optimized computing platform that blends a distributed SQL database with an in-memory key-value data grid. This is a SID-compliant, highly available system that can scale out easily to thousands and hundreds of nodes, and it can be deployed on-premise or in cloud. And here is, as you can see on this slide, the data can be distributed across cluster of machine and can be located both in RAM and on disk. And all the APIs you see here, like SQL queries, like SID transactions, computations, machine learning stuff, everything works smoothly and equally well over the data that is both in memory and on disk. So if to go deeper into the details, how the data is being stored, how the data is being distributed across our cluster, we need to talk a bit about the key value data grid. So the data grid is the way how the data is stored in your Apache Ignite cluster. Actually, if you take a look at this picture, we have 3 server machines, and every server machine is primary for a specific subset of data you have, which means that you can distribute all your data equally across your cluster, and this way you can distribute all the workloads that come into your Apache Ignite cluster. It's worth mentioning that there is a way for sure to enable data reliability. So for every entry you have in your cluster, you can have a copy of the same data on a different machine. And the cluster is highly available and fault tolerant, meaning that if during the lifetime of the cluster, one of the machines goes down, the cluster will automatically trigger this situation and will rebalance all your data you have in your cluster. And finally, as for the data consistency, if you need to use transactional operations, if you need to execute some transactions for your IoT data stored in your cluster, you can rely on our ACID transactional framework implemented and supported in Apache Ignite. And that's how the data is being distributed. This is how it's stored. However, when you need to stream your data from Spark, right? So we are streaming data from Spark into the Apache Ignite, you need to use a special component, which is a part of Apache Ignite cluster. On this side, we have our Apache Ignite cluster. And you can connect to your Apache Ignite cluster using so-called Ignite streamers, special streaming component that ingest the data in the fastest way possible into Apache Ignite. And in this, Spark streaming component will take this role. on this picture. So once the data is received by Spark from your edge devices, it will be transformed and streamed into the cluster of Apache Ignite nodes. And here is to the right, you can see like your applications. Your applications can be connected for sure to the cluster and can execute SQL queries, transactions, computations in parallel. Meaning that all the data will be streamed in real time, and at the same time, the data will be processed concurrently in parallel. Okay, let's speak a bit about additional APIs that will be available to you if you try to build such a software stack for your IoT solution. First, this is kind of SQL queries. So Apache Ignite can be truly used as a distributed SQL database, which means that not only the data is distributed, let me show. Not only the data is distributed across a cluster of your machines, but the indexes are distributed as well. So every node, which is a primary or a backup for a specific subset of the data, will maintain not only the data, but the indexes. And as I mentioned earlier, the data and indexes can be stored in RAM and on disk, depending on your configuration, depending on your requirements and resources. Next, when it's time to talk to your data, we decided to we decided not to reinvent the wheel. We rather decided to support well-known standard interfaces. This is why, for instance, Apache Ignite SQL API is fully NC99 compliant, which means that you can execute any SQL query that is defined by this specification, including distributed joins, including aggregations, grouping, and sorting of your data without any limitation or exception. Next, JDBC and ODBC are supposed to be the main way you are going to interact with your cluster. So for instance, you can connect to your cluster from any technology application you like Java.NET or C++, and select your data, update your data, or insert your data, whatever you need. So you are going to work with your HTAP platform, with your Apache Ignite cluster, the same way you work with a relational database. The only difference is that in case of Apache Ignite, the data is distributed. Next, this is actually one of the execution flows of a query. And here we just want to emphasize that we don't support only simple SQL queries. But again, you can do joins, you can do aggregations, groupings, and all this means that eventually you can execute ad hoc queries on top of Apache Ignite cluster. Next, sometimes it's, when we talk about SQL queries or basic operations, we get the data from our cluster, bring it to our applications, do something with it, and send it back. In this scenario, we move the data all the time between our cluster and application. This is kind of a standard way you work with a relational database. But sometimes the amount of data can be so big that it will affect your performance significantly if you move the data all the times. And for these scenarios, we suggest using Compute Grid, which is a MapReduce or fork join framework that is developed specifically for Apache Ignite, which is kind of one of the main components available in this product. And here is the main point of this component is that you can execute collocated computations in your cluster, meaning that you don't need to bring your data to your applications. You can rather create some computation and send it to your cluster nodes, to the place where the data is. Next, for the Spark users, as I stated earlier at the beginning of our talk, Ignite and Spark are integrated. And the integration happened at the level of RDD's APIs. So Ignite shared RDD is one more RDD that is available for Spark users. And the benefits of that RDD first is that it's kind of shared RDD, meaning that all the Spark workers, all the Spark applications you have in your deployment and solution, they can share the state of the same RDD. And that RDD is mutable. It's mutable because actually that Ignite shared RDD is just a wrapper and advanced API on top of your Apache Ignite cluster. And the good thing about that is that we don't need to copy all the data from Ignite to Spark all the time if you use our shared RDDs. All the data is already in Apache Ignite cluster. And which means that when you decide to execute some operations on top of using Ignite shared RDDs, using Spark RDDs, then you are not going to do all this copy-paste of data from one machine to another. The data is already in the cluster, and all these shared RDDs can share the state between all the Spark workers you have. And as for the other benefit of using that integration is that you can leverage from Ignite's SQL engine. To my knowledge, Spark, we do know that Spark supports SQL queries, but at the same time, we know that it has lack of indexing, which means that every SQL query you try to execute probably will end up, will be doing a full scan over the data you have. But that's not true for Apache Ignite. For Apache Ignite, as we already know, you can index all the data you have. And once you do this, you can execute all the queries in logarithmic time, which is much faster, right, in compared to the linear time. And finally, for those guys who do different machine learning, we do provide our own machine learning library on top of Apache Ignite. That presently, at this moment, in the current and the latest Apache Ignite release, we implemented distributed co-algebra, so you can work with dense and sparse matrices. But and in the nearest releases, you can expect to get from us implementation of well-known distributed algorithms such as k-means clustering, linear and logistic regression, decision trees, and so on and so forth. So if you're a kind of scientist or researchers, give a try to machine learning grid. Okay, well, all of these components, we discovered that all the software stack that is developed by Apache Software Foundation projects and communities allows us actually to build an IoT solution from the bottom to the topest level. So you can create we have a real-time operating system. We have a module that gathers all the data from our devices and transforms it. And we know where to store the data. And once the data is stored in our cluster, we know how to work with this data. There is a variety of different APIs available. And now let's take a look at the quick demo I prepared for you. Here I have a simple application. I'm going to start 2 Apache Ignite cluster nodes. The first one. Okay, we are starting our Apache Ignite cluster. It's kind of a pretty simple operation. You just need to pass a configuration and start your cluster node. Okay, here we have 2 cluster nodes up and running on my local laptop. It's good for the development. Now I want to see that I want to connect to my cluster from Management Console. I want to see that my cluster is up and running. Let's wait for some time. Okay, I have 2 cluster nodes, and I deployed 2 caches. The first cache will store information of all the sensors deployed in the field. And another cache, or you can think of it as a relational table, will store temperature that is reported by all these caches. Right after that, I'm going to start Spark Worker. That's a simple Spark application that will connect to Apache Ignite cluster. It connects by means of, let me show, special Ignite RDD. We need to create Java Ignite context, as it's shown here. And right after that, we need to create RDDs, Spark RDDs, on top of the caches that are already deployed in our cluster. That's it. Okay, let's see. Okay, Spark is connected in the client mode. We can see it here. And this application and this stack trace reports that Spark is trying to connect to our edge devices, to our IoT deployment, trying to get some information from there. And for the sake of the demo, I created a simple sensor data generator. So I will open a socket connection on a specific port number, and I will send different measurements into this channel. Let me start this application. Okay, it could connect to Spark. So actually Spark connected to this application. And now we can see that Spark, what it does, if to take a look at the source code of our Spark application, it receives all the data using Spark streaming capabilities from this localhost port number. It transforms it, prepares special tuples, and saves all the data into the Apache Ignite cluster. And then periodically we started a special timer task that tries to select all the sensors, number of sensors that report temperature between 70 and 100 Fahrenheit. This is what happens with this application. And at the same time, we can see that the data of our cluster, let me see. We see that the data is being changed all the time because the cluster evicts old data automatically according to our configuration. And finally, here as you can see that you can execute SQL queries from Spark using Ignite engine. This is how it looks like from your Spark application. And you can do the same from, let's say, from any other tool or application you need. For instance, if I connect to this cluster from this management console, Apache Ignite web console, I can execute the same SQL queries from here, trying to get maximum temperature that is reported by my sensors. Or for instance, I want to find this query that it tries to join the data stored across different cluster machines. And here is I'm trying to find the maximum temperature reported by sensors deployed in the United States. So these are the boundaries of the United States. Okay, that's all from my side. So I will be pleased to answer your questions.
Thank you, Denis. Give a big hand to Den. We've got a couple of minutes left for questions. If you do want to ask any question, there are 2 mics on either side of the aisle. Please walk up to it and make sure that make it brief. Go ahead.
I have 2 questions for you. How do you distribute the data? Do you have any kind of sharding involved in this?
Partitioning.
Partitioning?
Partitioning. We partition the data. So for every data set, for every record you have, there is a primary node and there is a backup node. And eventually, all the data that you will store in your data, in your cluster, will be distributed. So for some of the data, there will be primary nodes, and for others, so every node will store a primary subset of the data and backup subset of the data.
Okay, and what about the point of failures, like?
No, there is nothing like that. So all the nodes in Apache Ignite cluster are equal, meaning that there is no any master node, there is no any coordinator. It's a kind of self-healing cluster, you know.
Peer-to-peer, complete peer-to-peer. Yeah. Okay, all right. And you still provide ACID compliance on this one?
Yeah, yeah, correct.
All right, thank you.
Okay, quick, make it quick.
Okay. So I know in Ignite you can define an affinity key. So is there any concept that you can kind of group by those affinity keys? So when I send my query, all those keys fall in that group will be executed on the same node.
So the question is about SQL queries, right? About how we execute SQL queries?
Not SQL queries, like in Ignite you can also send your own custom code.
You mean computations, right?
Yeah.
Okay, so here is, like it's shown here, if you want to send a computation to a specific node where the key is, you just need to use a special API we provide. Inside of your computation, you just need to send that this computation must be sent to the node which is a primary for this key or to the subset of these keys.
So can I define a group of key to
Yeah.
that node?
Yeah,
Not
you can
just-
send to the partition. Yeah, there are different ways how you can easily do this in Apache Ignite cluster using compute grid API.
Okay, thank you.
You're welcome.
Okay, we're out of time. Give a big hand to Denis. Thank you.
Thank you.